Welcome back to Physics Daily, and we are back today with another classic problem which is related to classical mechanics. So let's read the question. The acceleration of gravity can be measured by projecting a body upwards and measuring the time that it takes to pass two given points in both directions. Show that if the time the body takes to pass a horizontal line A, which is this, in both directions is TA, and the time to go by a second line B in both directions is TB, then assuming that the acceleration is constant, its magnitude is g equals 8h over ta squared minus tb squared. And it is defined that h is the height of the line B above line A. Okay, so in order to approach this problem, let's draw a free body diagram first. Alright, we are done with drawing our free body diagram. How do we approach this problem now? Okay, so let's say that the initial velocity of the object when launched from point A is basically VA. Let's assume this. And when it reaches point B, the velocity of the object over here, let's say this is VB. Okay, taking all of these into considerations, we can say that the time of flight with reference to the line A over here, this can be expressed as TA is 2VA over G, right? Okay, and similarly, we can say that TB is what? 2VB over G, right? So let's label these equations as equation 1 and this as equation 2. Okay, now moving on, we can also assume that the maximum height achieved by the object with reference to the point A over here be h max A, and that with reference to this point B over here, the maximum height this be h max B, right? So we can say that h max A over here in terms of the variables we have can be written as, right? And h max B with reference to this point over here can be written as VB squared over twice G, right? Let's label these as equations 3 and 4. Alright, so from the given figure, we can say that this h over here is the subtraction, the difference between h max A and h max B, right? So we can say that h max A minus h max B is basically h, right? Okay, so if we follow this thing and plug in equation 3 and 4 over here, we have that this is basically VA squared over twice G minus VB squared over twice G is equal to H, right? We can pull out the two G's over here in the left side as a common term, and we can write this as 1 over twice G times VA squared minus VB squared is basically H. Okay, now what do we do with the VA squared and VB squareds inside the brackets? Well, we go back to our equation 1 and 2, right? Equation 1 over here and 2 over here kind of tells us that, well, VA is basically what? TAG over 2, right? And VB is basically what? TB over G, TB times G over 2. Okay, so we have VA and VB over here, and if we plug these two things inside of here, we get that this is 1 over 2G times TAG over 2 squared minus TBG over 2 squared, and this is basically H. Okay, and if we do further simplification, we have that right? And so we can say that the representation of G over here is basically 8h over t a squared minus t b squared. Well, this is the solution of our problem at hand today. Haven't we proven this? Well, yes we have. Well, that's all.